So we start by going to a model wizard where we select our space dimension. We'll be dealing with the 1D, then move on to select our physics. Under electrochemistry, select the battery interfaces, have lithium-ion battery. Move on to add, move to the steady, and we'll be using a time dependent with initialization. Done, then we move. So this brings us to our work interface where we quickly input our parameters that we'll be using. So we'll be using the battery capacity. You have to input the parameter for the battery capacity. And also we have to input the value for the initial cell voltage. This is the battery capacity, and this will be the initial cell voltage. That's the initial cell voltage. So okay, so let's quickly draw our geometry. Build our geometry. So the geometry is going to be an interval with going to specify as interval length. So as you know, we have the positive, the electrode separator, and the positive anode. So we have 30 and 6. Yeah. Okay, so we've been able to build our geometry. What we'll do here is we'll add our materials. Let's go. We're going to add this first. We want to bring this up here. Okay. And we're going to add our graphite. Also, we'll bring it up here. And we're going to add our positive electrode, which will also bring it up here. So even before we continue, we're going to insert the functions, interpolation. Interpolation is going to come up here. So Let's delete this interpolation in here, and I'm gonna create this interpolation. Move to functions, interpolation. Okay, this makes it easier. Then I'm going to choose file, browse, and it's going to be the battery 1D drive cycle data. This is what we're going to use. And we'll import it. Implement is and going to name the function in my drive. And so now we have, so as we move on, some of our variables will be defined. Some are not defined yet, however, some will be defined. Some will be defined. That's when we move to our variables. We want to add, after we add our variables, most of these unknown variables will be defined. So let me add our variables. And we're going to load from file. So that will be the battery management variables. Okay, so we have this as our battery management variables, but most of these things are not defined yet. But we're going to define some of them as we move along. And also we want to add this to the battery management variables. Add I right. It should be a minus underscore 1 2 driving. These are capital T, sorry. Driving. Driving. Let's see. So kindly note that This letter is it's caps I. Caps I. Let's see. So this internal defined variable is used about will define the constant current that will completely charge or discharge the battery in an hour. So it's defined as the initial cell charge distribution node, which I will add as we move on. As we move on, I'll add the initial cell charge distribution node to it, and it will define appropriately. So most of these expressions are not defined because I'm yet to add some one or two steps to it. Then realize that they will all be defined. So kindly follow as I move along. So what I want to do is I want to add material link. That's what I want to do now. I want to add a material link first. So we have the material link one. Then I want to add another material link, which will be the first one is for the electrolyte. The second one will be for the graphite, and I'll add another material link for last material, as you can see in here. So we're still moving on, and I'll add, like I said earlier, I'm going to add the initial cell charge distribution to this work. And under it, we have the negative electrode, which I have to select. I'll have to select the negative electrode. And I'll have to select the positive electrode. But before that, I have to start from the lithium-ion battery. I have to start gradually. So let me start gradually. I move to the electrolyte. Everything is defined. No flux. Insulation. Then move to the initial values. Before we come to the initial values, so before we move to the initial, so we have to add the porous electrode. And add a porous electrode. And the porous electrode has to be, yeah. So the first porous electrode in here, and when we move to down, first move to the electrolyte property. We want it to be user defined. No, when we move to the electrolyte material, we want it to be material length 1. That's for the porous electrode. So it's actually has to be porous. And when we move to the particle properties, it has to be intercalating. We move to the electrode properties, it has to be also the material into. Then the volume fraction, electrode volume fraction, which we define it as dot EPSS. Sorry, all this has to be in small. Then this would be 1 minus that. Okay. Okay. So we're done with the porous electrode one. We add, let's add another porous electrode. That's porous electrode 2. Where is that going to be? It's going to be here. So as we did for the porous electrode 1, first we went to the electrolyte material. Same here, we go to the electrolyte material. Then, sorry. Then we move to the electrode properties. Then as we did over here, same thing for that. And we have this as well, this way. So you just have to follow the procedure that I'm doing, and you'll be able to define that. Then I want us to add a separator. So what will the separator be? We've done this, so separator obviously is here. So we'll have the electrolyte passing through the separator as well. And now for the separator, we don't have any electrode material running. We just have the electrolyte defined in here. Then move to our initial cell voltage. This initial cell voltage, we are going to use what we use for our parameters in here. And the cell so the battery cell capacity is going to be this. So makes it easier to navigate on. So now you're able to select the negative electrode. You're able to also select the positive electrode. in here. What I want us to add is an electric ground. So I want us to add an electric ground. Add an electric ground. Where is the electric ground going to be? It's going to be right here. So that's where our electric ground will be. And we need to add an electrode ground. Sorry, an electrode current. So where is the electrode current going to be? It's going to be at the last end, and it's going to move with this drive. Output. Has to be I. So we'll get it rectified. Unexpected units of I. As we move on, it will change. So as you can see, most of our variables have been defined now. Most of them. Currently, most of them. Most of them. But let's continue. We'll define everything will be defined. Everything is going to be defined. So let's add what we can do here is to so what we can do here is to add selection and explicit. Explicit is what we're going to add first, and this will be this will be the negative electrode. What's to be domain 1? Let's duplicate this so that you can no, let me just take my time and do it easier so that nobody gets confused. So I'll add another explicit, and here will be the separator. So then I add another explicit, where here will be the positive, obviously the positive electrode. Then what I'll do next is to add a domain probe. And before I add domain probe, let me add global probe rather. let's delete the domain probe first, and let's use the global probe first. This will be the cell voltage probe. The expression is going to be the cell voltage that is cell voltage. Then after adding the cell voltage, what we'll do is we'll add functions dot non-complex and add integration. Integration go with a negative. Select the negative electrode. Then we had another integration for the positive. We add another integration, which we'll call as the first CC, and it will be a boundary up to 4. Then we add another integration, which will be negative CC. And that will be here. Sorry, that will be the boundary. Then we add another integration for the separator. Boundary. First boundary. Negative separator, then we add the positive end of the separator. Positive separator. You see, most of our variables are defined now, except for this. So I think I made a mistake when I was typing the driving. It's to be with a small I. So now everything has been defined now. Everything has been defined now. If we check all our work, everything has been defined now. So I think what is left is within the materials, this part. I think that's what is left, and we're gonna define that. We're gonna define that. We have a transport number, diffusion coefficient. Okay. Mm-hmm. Okay. Go to basic definitions. We want to check our properties. We check our electrolyte conductivity. Check the species properties. We want to check the electrolyte salts as well. So, what we'll do is we'll define some of the properties for the reference concentration. We're going to define it as 315. We're going to put some values in there. Forward, move, minimum electrode state of charge going to be 0. Maximum electrode state of charge is going to be 0.98. Equilibrium potential. Then we have the temperature derivative. Q equals to T equals 1 SOC. State of charge. We will not have SOC in here. So I'll get back to this again. Let's continue. I'll get back to this. So now I move to mesh our work. using a physics controlled, which quickly builds if the meshes are work. So what I'll do is we'll continue the second part of our work next video. I hope we're able to get to this point. So I'll end at this point and continue with our work where we'll be able to compute the study, complete this work. We'll make some modifications in the property, material property over here. So I'll see you in the next video. And if you have any questions, kindly let me know in the comment section. Thanks.